So what kind of relationships can we work with then and build up with triples? One of the handy ones here is integrating different data sources, right? So you're working with, you've got some problem to solve, and that problem you're trying to solve, you've got some initial data. And this might be because a couple of companies have merged, or it might be because different organizations within the same company have each independently built up some store of data. That certainly happens, right? I used to work at a brokerage firm on software that connected traders to markets. It was one of 5 systems, 5 distinct systems that did that exact same function, just the way things happened. But anyway, I can take a triple and say that this customer ID is the same as this other customer ID. And now I can set up my queries pretty simply so that when I'm asking about customer 123, I'm also getting back the information I know about cus ID 456. Another example, I can reconcile data. And I was thinking about this later. I actually should change this example to one I like better. I read some time ago the number of different ways there are to transcribe the Arabic name Muhammad. And I think it was on the order of 17. I don't remember the number exactly, but it was more than 10. So if you've got data starting off in Arabic and you're translating it to English, or even just simply transcribing it, you've got a lot of different ways that data might come to you, depending on who's actually doing the transcription. So it's kind of handy to be able to have something that says, by the way, these are all the same. You know, it doesn't matter if you spelled it M-O-H or M-U-H, however you do it, it's the same name. It's based on the same transcription. Another thing we can do is have classes, right? So we can have the class shirt and specify that some item, some resource, is a type of that class. The example I was given is that a Henley is a kind of shirt. I don't know about you, but it took me a while to figure that. So the person who presented that example seemed to take it as given that everybody knew what a Henley was. And at the time, I had no idea. So I learned something. And another example here is being able to connect mentions of an entity to a document. So we can say, for instance, that this actor was in. Let's see. Let me back up. We can say that for some newspaper article, for instance, that this person was mentioned in that newspaper article. Maybe we've got a URL that points back to where we found that newspaper article in the first place. So I mentioned that SPARQL is a standard query language, and I wanted to give you a couple examples of kind of what it looks like, just to give you a sense. So this first one, and I've got about 4 or 5 of these, not intended to be an eye chart, hopefully you can see it clearly. But this first one is a simple query. So what I'm asking here is select count distinct. So I'm saying I want you to find distinct values of S, count them up, and I'll look at that as count. So I'm naming that. The where clause here, I've specified a predicate and an object. So essentially I'm asking, tell me how many people we have in our database who were born in Ukraine. Okay? Let's see. The first and second values are generally represented as IRIs, which is basically a URI, except the I is international, so it's got a little more flexibility about what characters you use. The last one there can be an IRI, or it can be a scalar value, a string, a number, so on. Right. So that's a simple query, and I don't know about you, but when I look at that, the first thing I'm struck by is this is pretty similar to SQL, right? We've even got some of the same keywords. We've got select, we've got where. In SQL land, we can do things like the as count there. Question marks are a little different, but not that different. We can also do some discovery queries. So this one is saying, I'd like to know all the information we have about this Weird Al guy. So this is going to come back with a set of triples, where the subject of those triples is Weird Al Yankovic, except here I'm saying I don't know the official representation, I don't know the IRI who represents Weird Al, I just know the name. So go look up the IRI and then tell me what you know. This one's kind of nice. We can do some transitive queries. Now, I want to call your attention to the star after has parent. So if I did this query without the star, then what I'd be saying is, I want you to select the people in my database, the resources, whose parent is Joe. So in other words, I'm asking, who are Joe's children? By putting the star there, I'm saying, and who has a parent who has a parent who is Joe? Who has a parent who has a parent who is Joe? And so on. So here I'm asking for the descendants of Joe. I mentioned that this is similar to SQL in a lot of ways. I want you to pause for a minute, for those who have worked extensively with SQL, I'm sure many of you have, and picture writing that query with SQL. It's a little harder than just adding a star. Yeah? So that's pretty cool. We've talked about inference, and so here's one example of what an inference rule looks like. So what we're saying here is that a person who's born in a place, and that place is in a second place, so we've got the country there, then that works out to the person who's born in that country. Yeah, and I've got an example later I think I have an example later that makes use of that. And finally, there's also an update capability within SPARQL itself. So in any triple store that supports update, you're going to be able to do statements like this. You can insert some new triples. So in this particular example, I'm telling my triple store that Odessa is in the country of Ukraine. Combine that with the inference rule above it, and now I can ask for people who are born in Ukraine, and I'll get all the people who are listed as having born in Odessa. All right, I'm going to move on to values, because remember we're talking about the combination of documents, triples, and values all within one database. So I wanted to clarify what I meant by values there. And by values, I'm basically talking about scalar values, simple numbers and strings and dates and things like that. But we can do some pretty powerful stuff with that simple information. So let's suppose you want to buy a TV. So you go to Amazon, let's say, and you type in TV. And what Amazon will do is it'll give you some facets on the left side. Here we go. And one of those facets will be brand. What brand of TV do you want to look at? Do you want to look at Sony, and we've got in parentheses 37, and we've got Vizio and 24, and so on. So it's telling you, here are the different brands that are available, and here's how many of each of those we have that you can take a look at. You can click on one of those, and you've just narrowed your search. So it's a way of exploring the data. We can do aggregation and visualization with values. So here we've got some bar charts, but we've also got a map there. We saw geospatial values earlier in that example document. So even though I said scalar values, and I'm including geospatial lat longs in that. So if we've got geospatial values, obviously we can put those on a map. That's pretty straightforward. With some decent geospatial capabilities, we can also do things like draw polygons and say, this is the place where I care about, essentially doing a geospatial facet. And analytics, of course. A lot of times we're interested in the values that we find in our database, but not so much the individual values. We want to find out, what do these mean together, right? What are the averages? What are the totals? What's the average sale for each of our salespeople this past quarter? Who sold the most? Things like that. So with values, we can run functions like this and provide additional interesting information. With a little note in there that, at least in MarkLogic, we can build custom user-defined functions. I'm actually intending to write one very soon. I have a 14-year-old daughter. I have two daughters. One was 14, and I suspected that she was taking her phone upstairs at night and texting her boyfriend. And turned out that she was. And, because we have a rule, it's like 9 o'clock, phone should be downstairs. We've been lax with it because she's been very mature and all that. It's great. what I did is I downloaded the month's texting data from AT&T, because I may be a parent, but I'm still a geek. So I took the data about the text, put that into a database, and my next step is to write one of these user-defined functions to separate out the time information and get myself a little facet showing at what time of day were the texts being sent. I know what I'm going to find, too, so she's in for it. So co-occurrence is another example of real-time analytics. The idea of co-occurrence is it's great to see a list of what medicines are in our database, and it's interesting to see a list of medical complaints that people have. But it's really interesting if you can put those side by side and see what occurs together. Right? So this is an example of two-way co-occurrence where I'm taking two of those values and putting them together, but we can do n-way. So think about, I want to know about medical problems, prescription drugs that people are taking, adverse events, and who the prescribing doctor was, let's say. So 4 things. And if you find yourself, you do that analysis and what gets presented there, picture you've got a particular doctor who is often prescribing some medication for some illness and frequently getting this adverse result. Maybe we should go have a chat with that doctor about maybe that's not the right medication to be using there. So again, this is a way of taking a look at a large data set and being able to learn something about it. So that's what I mean by having values in the same database. Is this is the kind of stuff that we probably expect from most databases. I just want to make the point that it's there too. You're not giving that up by moving to a document store. And last, we're going to get to what happens when you combine these things. Of course, some combinations work better than others. We've got our SPARQL example here, which is not quite as good as a fork, and it's not quite as good as a spoon, but it provides the functions of both. When you get the right kind of combination, though, you can get something that's more powerful than either one by itself. So I've talked about documents, and here we've got an XML document. It's an article. We have a title. And then we've got that sem triple thing in there. So we've got an XML representation of a semantic triple, subject, predicate, object. And you'll see that that's embedded right in the document itself. I can also have triples that are outside of the standard documents. MarkLogic likes to call these managed triples because MarkLogic is handling where those triples live. I like to call them free-range triples because I just think that's a nice thought. I picture little chickens with the triple symbol on them. But the point is that we can do both of these things. We can have triples that are embedded in documents and triples that are kind of off on their own being managed externally. And even better, we can add additional information, right? So a triple, we've got the subject, predicate, object. That's 3 things that we're connecting together, right? Sometimes we want to add some more information, though. We might want to know, when was this triple true? What's the source of this triple? How sure are we that this fact is actually a fact? So we can annotate that because, hey, it's XML. Just throw some more information in there. The way that this data is stored and even the way it's indexed, adding this extra information won't throw off the indexing. It still will just pull out the parts that it needs to see. I should also point out that while we're showing XML examples here, JSON works just as well. We've got a JSON representation. So how does that help us, though? All right, well, we've start off with a triple, and let's say we've got a whole bunch of triples put into our database. And we've got some query that we want to run. With most triple stores, you've got your SPARQL query, and that SPARQL query is going to be run against your entire triple store. So if you've got 1 billion triples in there, you're going to run that query against the whole 1 billion triples. Wouldn't it be nice, though, if you could say, you know what? These are the triples that are most likely to be relevant. So let me just run on those triples. So if you combine documents and triples, you can say things like, I want you to find a set of documents that meet these criteria, and then run the SPARQL query on the triples that are embedded within those documents only. So it gives us a way to partition and focus on the information that we care most about. All right, now this next slide might look a little bit intimidating at first glance. But it's actually pretty straightforward when we break it down. The language that we're looking at here is XQuery, which is a language that is useful for working with XML. I'm going to point out that MarkLogic supports that as well as server-side JavaScript. So this example could be written in JavaScript as well. What we're doing, we've got a, I think this thing's got a, oh, here we go. So this part here is a simple SPARQL query. We're asking about Nixon and where this Nixon fellow went, and we figure we're going to get some countries back. But we don't want to run that against the entire set of triples. We want to focus that down. We're only interested first off in triples that we're pretty confident are true. And we care about when these triples we're talking about, right? So we only care about cases, we only want to know where Nixon went before 1974. And we want to make sure that our sources are reliable. So we're going to narrow this down again to say it's only if these facts were reported by the AP Newswire or the BBC, we're going to restrict our search to just those and see what we get from there. So which countries did Nixon visit before 1974 where answers have at least an 80% confidence and the source is AP Newswire or BBC? That CTS and query that you see there is identifying a set of documents, right? This, the bracketed stuff there. It's identifying a set of documents, and then the SPARQL query is running against just the triples that exist within those documents. That leads to a really nice performance boost compared to running every SPARQL query against every triple you have. We can do the opposite thing too, right? So if we've got a query where we want to find documents, we can start it off by saying, you know what, I want to make sure that these documents contain some kinds of triples. You know, maybe I want to only find documents talking about people who were born at a particular location. Well, I can use semantic inferencing to help give some context to that search of who was born where, and use that as I'm narrowing things down. And then from there, I can execute additional queries to find the documents that I'm most interested in. Another advantage of this, and here I'm comparing specifically to a case where somebody has decided they need both these things, right? They need a document store, they need a triple store, so they have them side by side. And I've actually got an example of this later on that I'll talk about, but if you combine those two, then you get a much simpler architecture, right? If we're looking at them separately, then in the middle tier, our application code, we're going to be talking to the triple store, asking for some information, set of triples. We'll get our response, and then we can go to the document store and ask some other question. So we've got a couple round trips. We need to bring the results together at the application level. Whereas if we do it this way, our database can be smart enough to say, just tell me what you need, and I got it. And I can use both the triples and the documents to provide the answer you need. So this gives us a simpler architecture which has the advantages of the application code, the middle tier is simpler. There's one less thing to fall down and die when you least want it to. And one less piece of software that you have to pay for and generally maintain. So that simplified architecture by itself makes a pretty good argument for combining those two into one when you can. Okay, so this, I mentioned we had an example, I have an example of a case where this is being done right now, where we've got the document store and the triple store side by side. So what we're looking at here is the general architecture that was used for the BBC Sports website previous to 2012. What's significant about 2012? Well, that's the year that London hosted the Olympics. So BBC figured that London's hosting the Olympics. People are going to be turning to BBC to see what's going on with their teams. So they've got a big responsibility to make sure that data is being displayed well, relevant, quickly, and so on. And this system had better be robust. So this is what they had started with. This is what they'd ran with previously, MySQL database, and they had a team of people who would build up static content stored in the database, and they'd serve that up. But they also knew, that they needed to serve up to millions of visitors once the Olympics started, and that people would be using different devices, and these updates would need to be coming out very frequently. And the static publishing model was just not going to get them where they needed to be. So they went with a different approach. They took XML data, put that into MarkLogic. They took RDF data, put that into a different triple store. And they came up with this dynamic semantic publishing model. It's a pretty cool idea, actually. The way they set it up is they'd have a template, so that instead of defining a page for Wayne Rooney, they'd define a page for a football player. And then that football player template, of course, could be populated by, well, here's the national team that he plays on, and there's information about that. We can also say that he plays in the Barclays Premier League and have some information about that, and so on. So by virtue of saying, we have all these triples that describe each of the people in our database, and the teams in our database, and the sports in our database, we can build out content in some really interesting ways. And with that model, they were able to support a lot of incoming traffic and support the interesting needs. Something we've talked to them about, haven't gotten to this yet, but funny thing is that BBC is actually inspiration for MarkLogic's semantic store capabilities. It was because of this use case that we said, you know what, this is something we need to do. They pretty much talked us into it, which is kind of fun. So it's simple enough to picture taking all that and putting it into the same database, and now instead of having to make these separate queries to say, you know, what XML documents do we want to deal with and what triples are we going to interact with, that information is all together in one place, and we can go with it from there. Again, I don't want to misrepresent anything. This is not BBC Sports model today, something we've talked to them about. They are using the triple store for some smaller projects. Okay. So we got speed and scale, automated publishing, and here we go. The dynamic semantic publishing model. So basically, this let them keep up with the enormous demands of being the official source of information for one of the world's largest sporting events. One of the interesting tidbits I remember hearing about this, I think it was a matter of weeks before the Olympics started. I guess it was our consultants who pointed out to them that there's some new features in MarkLogic 5, which is new at the time, that would be really helpful, and they actually said, okay, yeah, let's do that. So they upgraded, upgraded to a major new version of the system that was just out weeks before this enormous deadline. And it actually worked out well, so everybody was happy. All right, there's the example about the triples, about what league somebody is in and so on. So a couple numbers to throw around. One of the funny things I heard about this is that, or one of the stats I heard, is that during the Olympics, the 2012 Olympics, something like 1/3 of all the internet traffic in the United Kingdom was going through the BBC's website. That's a lot. That's a lot for one website to handle. And it worked great. So it was one of these happy success stories. So when does semantics help us? Well, I've got a couple of thoughts here about normalizing and linking across different sources of data. So that data integration problem is one that we face regularly, right? It's a very common situation that these different data sources creep up over time for a variety of reasons. Sometimes it's just inevitable. Sometimes it could be prevented, but doesn't. MarkLogic is part of healthcare.gov. 37 states, each presenting insurance information in completely different ways. That worked out fine. We did not have to agree on a common schema across all 37 states before we could start doing anything. We were able to bring everything in and get moving pretty quickly. We did not use semantics for that, just for clarity. So we can model relationships. We can give the facts that give us context, like we talked about the transitive connections of who's related to whom and where people live. There's just a couple examples of the kinds of context that semantics can give us. MarkLogic semantics in particular, we talked about the enterprise NoSQL database, and I'm happy to discuss that in more detail with anybody who would like to hear. But the key thing is that this is a place that's going to store all of your data. I made the argument earlier that if you've got relational data, that fits well into a document store. If you've got documents, obviously it's a good fit. If you've got triples, that's a good fit. So whatever your data looks like, this is one place that can handle all those different types. I said earlier, I did not come here to do a commercial, but I wanted to throw this up real quick with the idea of if you spot something on this that looks interesting to you and would like to talk more about or hear more about, I'm happy to stick around after this, and I'm also doing an office hours session tomorrow at lunch. And MarkLogic has a booth out in the exhibit hall, so we'd be happy to provide more information. The key takeaway is the three items up top: powerful, agile, trusted. This is how our customers view us, and we work hard to maintain that. So, with all that said, email, Twitter. The company MarkLogic has both a corporate site, www.marklogic.com, that's intended to provide kind of the business case and here's why you would find us interesting, as well as a developer website that's intended to provide more of the how. How do you use these features? How do you build applications, and so on. Again, I invite you to come to office hours tomorrow or to see me at the exhibit booth. And with that, that is the end of my presentation, and I'd be happy to take questions.
So on the semantic model, you have subject, predicate, object. That's very similar to an object graph model. Now, object graph databases have the ability to apply properties on relationships. Do you have that capability?
Yeah, so the question for those who couldn't hear it, in a object relational database? Object graph database, thank you. In an object graph database, there's the ability to provide properties on relationships. Okay. And so the question is, can we do that on triples as well? The answer is yes. So as we express a triple within the database, so again, we can do that with XML or with JSON, and we can annotate those triples to provide that extra information. So for instance, we had the example of adding a confidence attribute. So on the one about Nixon. So that's one example. Now in that case, what we're really annotating is the triple itself, but it's a matter of how you make use of that information, right? So if we said that, one thing we could do, we could add attributes or additional elements that specify something about when that relationship was true. So we're essentially describing the predicate in a temporal way. Does that answer the question? Sort of, okay.
Well, like the example you gave, you had the drawing with the electrical, and you said, he is not a very good electrician. You could say knows electrical work, and then have a property on there that says a little bit or a lot or something like that.
Okay, right. So in my example about the water heater, where I had my triple about Dave is not a very good electrician. So we could express that as a triple that says, Dave knows how to do electrical work. And then we could put something that says how true that is, how meaningful that is. And in this case, we probably want to supplement that with not very. Right? So we can maybe we'd express that as a confidence, and have the confidence be 20%. Or maybe we could have it as a matter of degree, where we could say the degree is low or have a 1 to 10 scale or something like that. But So there are actually a couple ways to approach this. One is to annotate the triple, like the examples we saw. The pure RDF way to do that is to have a to have a resource, an IRI, that describes the triple. And then we can have other triples describe that. Did I express that well? I don't think I did. So we can have a resource. Trying to remember how this works exactly because I haven't done it a whole lot. We have an IRI that effectively represents a fact. And that fact is Dave does electrical work or knows how to do electrical work. If we have an identifier for that fact, we can then have other triples that say that IRI, confidence, some number, or degree, some value, that sort of thing. So there is an agreed upon way to represent that kind of annotative information in a pure RDF sense. In our case, because we're storing it in XML or JSON documents, we have this annotation, a way of handling it. So we've tended to go that way. That said, I'm giving something up by doing that, right? Because those annotations are not accessible to SPARQL. So I can say things like, I want to pay attention to the documents where the confidence is at least X or only that sort of thing. But my SPARQL query is not going to see that confidence attribute. If I do represent things in a pure triples way, then SPARQL can see all the information and get a more knowledgeable response.
Yeah. So how complex can you go? I'm looking at comparing that to something like Neo4j,
Okay.
a purely graph database, where maybe a better example is employee with this name is employee of company with such and such name, and the is employee of can have a property that is like employee ID.
Okay.
So you could actually do a search on any project that anybody at that company is working on who has an employee ID of such and such. So there's that part. The other part is, I know RDF, at least way back in the day, the very beginnings of the semantic web movement, it was a very point-to-point process of getting to the relationships you might be looking at. So one of the things I like about object graph databases is sometimes you can actually turn that on its head and say, I'm looking for this, and it's completely anonymous to me right now, but it has these types of relationships to this object. So I have concrete information now. Are you able to support that with the current version of SPARQL?
Okay. So, do you have an answer for?
I think what you're talking about is an RDF model with blank nodes. So your example would say this person has employment this thing, and then you can apply lots of different properties to that employment. So you can say, this employment is for this employer. It has this employee ID. It started on this date. It ended on this date. And you can make that as complex as you like. You don't need to assign a URI to that one or an IRI to that node. It's all a blank node. It's just kind of like a container for property.
Right, so the way to do that with triples would be to say we've got an IRI that identifies an individual, and we can say that IRI has ID, some value, and then IRI works for some company, IRI worked on some project, and then from there we can combine those triples in a SPARQL query to say, I'm interested, I've got this ID, so find me the IRI that corresponds to that ID, and then find me other information about that IRI. So we can kind of go that direction. Does that make sense? I feel like there was something else I wanted to say with that, and it escaped me. So, is that okay?
So what's the sort of developer average approach? Is it available to download, reinstall, work on it?
I'm glad you asked that. So MarkLogic is available on the web. Just you can download it, and you can get a free developer license. The developer license is good for basically whatever you want to do with it, except go to production. When you're ready to go to production, then we need to work through the license. Some of the license options, let's see. You can get this as an AMI on Amazon and pay by the hour if you choose. You can buy a perpetual license. You can do. Oh, right. We've got a program going on right now that for qualified new customers, you can get a free year of MarkLogic on Amazon to basically get going and get something into production. So that includes production use for that case for the 1 year. But yeah, basically if you go to developer.marklogic.com, there's a download button there. You can download MarkLogic itself along with, we've got a bunch of other tools there. And I mentioned earlier my role is the developer community manager. So part of that is I work with community members to build additional tools on top of or around MarkLogic. Some of the tools the company is producing are built on GitHub to make them very easily accessible and get community input that way. So for instance, we have a Java API to interact with MarkLogic. We also offer a Node.js API. And if you're not in one of those two environments, we've got a REST API. So whatever language you're using, as long as it can do HTTP calls, you can interact. When you need to extend the capability of the REST API, there is an extension mechanism. You can write code in server-side JavaScript. One of the neat things, actually, I think about the Node middle tier. So we can do native JSON storage. You can write server-side JavaScript, Node in the middle, JavaScript on your front end. Because of that native JSON storage, of course, you don't have to do any transforms. So think in terms of your relational model where you're transforming things from the database to the middle tier at least. And yeah, there's tools like Hibernate, but that still takes work. It's still non-trivial. And if you just don't have to do those transforms, that saves a lot of time and effort. One of my colleagues likes to say the least buggy code is the stuff you don't have to write. So, other questions?
So what are the implications of indexing everything? Every line of text, every tag, everything?
Okay.
Why doesn't everyone do it?
Why doesn't everyone do it? So the question is, what are the implications of indexing everything? And so something I've heard people say in the past, like, oh, you do XML, but XML is so big. It's bloated and it's blah. And yeah, I'm not going to argue that point. But what we do is when we get data, the XML itself is actually stored in we kind of break it down and store it in a hierarchical structure that's compressed on the disk. So that part of it ends up being a lot smaller than it was in text form. And then with the indexes on top of that, if we just go with the universal index, it ends up not being that big, like compared to, sorry, let me back up. The overall size ends up being not more than typically the input data. And then you can build some other indexes on top of that as you typically need to make, you want to be able to do range queries against dates. So you can say, I only want stuff before the year 2000 or so on. So as you add additional indexes, obviously, you're taking some more space for that. The reason the universal index in MarkLogic is not only on by default, but you can't really turn it off. You can tweak it a bit, but it's always on. It's just that it is proven over time to be so incredibly useful that everything just happens faster because we have that data. We have that structure. So, like I said, there are some tweaks we can do with it. There are a number of settings. One of the things we talk about is there are more than 30 different kinds of indexes that you can work with in MarkLogic. The default out-of-the-box stuff is intended to be a realistic, production-ready setup. And then you can tweak from there based on your application needs. But one of the examples is fast phrase searches, right? So if you want to be able to support people saying, in quotes, yellow cat, just to pick a couple random words. If you turn off fast phrase indexing, then, okay, fine. We still have the universal index, so we know what documents have yellow. We know what documents have cat. And so we can kind of put those two together, and we've got a candidate list. And then we just need to go through those and figure out where yellow and cat occur together. With the fast phrase index, it's a simple lookup. You just go right to the answer and pull that back. So we allow a lot of trade-offs between time and space, runtime and space, but the universal index is kind of the starting point for that. So what are the implications of it? We've actually, in MarkLogic 7, which came out about a year and a half ago, we made a significant reduction in the amount of storage space that's expected and required for MarkLogic data. So if you happen to know about MarkLogic and used it 3 or so years ago, it's gone down since then. And that's not something we've gotten resistance from. I'll say that. Any other questions? Okay. So the question is, we've been talking about searches and finding data, but what about updates? How does that happen efficiently? First thing I'll mention is that MarkLogic is an ACID-compliant NoSQL database. It's not something you see together very often. MarkLogic uses the MVCC, the multi-version concurrency control approach. So basically, when we insert a document, it's got a born-on date and a died date, timestamps for each of those. Initially the dying date will be infinity. So that way, when we're querying at a particular timestamp, and this document is present at that time. When we update a document, we're not touching the original. Okay, so we're not updating in place. What we're doing is creating a new document with a timestamp, such that the dying timestamp of the old one and the born-on timestamp of the new one, those line up so that at any given time, we're either seeing that version or that version. Never in the middle, never having to worry about a lack of consistency. That approach means that when you're doing a simple query, something that's not going to do any updates, we can run fast because we don't have to worry about the write locks. So let's see, does that address your question? Good question. So I mentioned that each document, when we do an update, the old version of that gets a timestamp at which it's no longer relevant. It's been deleted effectively. So the question is, are we keeping those forever? And the answer is no. We have a background process that runs through and cleans out the old ones. And again, we're not updating anything in place. I don't want to go too deep into the individual structure. I'd be happy to go as deep as you want later. Just not sure this audience wants to hear all of it. But the nutshell version is we don't update in place. It's more of a copy the still good stuff to another place and then delete the original set. So that process, again, happens in the background. We provide control over how much CPU that can take up. We do provide control over how far back that can be. So the default is that anything that's been either explicitly deleted or updated and therefore deleted is a candidate for going away. In practice, some of our customers want to be able to say, well, I want to be able to ask what things looked like last Wednesday, or anytime within the last week. So, okay, fine. We can set up a trailing timestamp that says we're going to keep everything between now and that past timestamp. And that timestamp advances as we go through time, cleaning up everything before that timestamp. Okay. Other questions? All right. Well, thank you very much for your attention. I appreciate it. And